Hi everyone, this is Miss Cohen, and this is Chapter 1, the test review on rational numbers. Okay, for problem number 1, it's asking that you select whether each number in each situation is rational or irrational. So you need to know that a rational number can be written as a fraction or as a decimal. And the decimal can be either terminating or repeating. So the very first one says the volume of a cylinder is 17 over 3. 17 divided by 3 cubed centimeters. Is that a rational number or irrational? Is it written as a fraction? Yes, so this is a rational number. Okay, so look at this very first part right here. A Gatorade bottle contains 59.1 with the bar repeating over the 1 milliliters of liquid. Would that be a rational number or would that be an irrational number? Well, can you write that as a decimal? I'd say yes, you can. So that means this is a rational number. The next part, the area of the floor covered by a circular rug, which is this over here, is 7 pi. Well, pi is irrational, and if I multiply by 7, it's still going to be irrational. Each side of a cube measures 13.5 meters. Is 13.5 rational or irrational? Well, 13.5 is 13 and a half, or 27 over 2, and that is a rational number. If you can write the number as a fraction or a decimal, then it's a rational number. Okay, what I'd like you to do is your problem 1A. Okay, we have question 1B. The diagonal of a rectangle, so that's the part that's in black right there, that diagonal from the corner to corner on opposite sides of this tile, tile A, the diagonal is 5 square root of 15 inches long. The diagonal of a rectangle, tile E, is 4 and the square root of 36 inches long. Which tile has a longer diagonal? Okay, so this is how we're going to calculate it. For tile A, we're going to put into the calculator 5 square roots of 15. You're going to put the square root of 15 times 5, and you're going to come up with a number. Okay, when I put that into the calculator, I get a number that is approximately 19.3649, and then there's other numbers that are not repeating behind it. This is tile A. Tile B is 4 square root of 36. So I'm going to put into the calculator the square root of 36, which is 6, and I'm going to multiply that by 4. And 6 times 4 equals 24. So I can see that tile B is larger than tile A. So it says, explain in detail how you got your answer. Tile B is, or has a longer diagonal. Okay, so I multiplied the outer number times the square root number, and I could see which number had the longer diagonal. So 4 times the square root of 36 was longer than 5 times the square root of 15. Okay, question number 2. It says sort the expressions into the boxes. We're going to have to simplify those exponents, and then we're going to have to put them into the correct bins. So I'm going to tell you that this problem, number 2, is worth 1 point for each one. The bins is worth 3 points total, so it's a half a point for each one. Okay, so let's look at this top problem here. We'll say this is number 1. 8 times 2 to the 0 power. So that is 8 times 2 to the 0 power is 1. 8 times 1 is 8, and 8 to the 0 power, 8 to the 0 power is equal to 1. So which bin does that go in? Well, 1 is less than 8. So I'm going to go ahead and I'm going to write, well, let's just say problem number 1. That way it'll make it easier. Number 1. So let's number this number 2. In the calculator, take the square root of 60. And that is approximately 7.745 ... That number is less than 8, so I can go ahead and write that into the bin. Number 3, 2 to the negative 5 divided by 2 to the negative 5th power. How do you make the exponents positive? Well, you have to do the reciprocal. So when I do the reciprocal, two to the 5th divided by 2 to the 2nd, right? Because the 2 to the negative 2, that is in the numerator, and it would go to the denominator. And 2 to the negative 5th would go to the numerator. And now I have a division problem, so we're going to keep the base. And we're going to subtract our exponents, 5 minus 2. So 2 to the 3rd power means 2 times 2 times 2, which equals 8. Okay, so that means number 3 equals 8. All right, so let's try number 4 here in the second row. We're multiplying terms with like bases, so that means I'm going to add my exponents. 2 to the 8 plus negative 2. That's the same as 8 minus 2. 8 minus 2 is 2 to the 6th power. So 2 times 2 times 2 times 2 times 2 times 2. This is 4. That's 8, 16, 32, 64. This one equals 64. That's greater than 8, so I'm going to go ahead and put number 4 over there in that bin. Negative, let's say this is number 5, sorry. Negative 2 to the 3rd power is negative 2 times negative 2 times negative 2, 3 times. So negative 2 times negative 2 is positive 4. And I still have another negative 2. Positive 4 times negative 2 is negative 8. That number is less than 8, so I'm going to put that in the bin where it says less than 8. All right, number 6. I'm dividing terms with like bases, so it's very similar to number 3. It looks like I'm going to subtract the exponents. 6 minus 7, so that's 8 to the negative 1. How do you make an exponent positive? We're going to do the reciprocal. So now it's 1 divided by 8 to the first power. And so that is simply 1 over 8. That is less than 8. So we're going to say number 6 goes in that bin. Please make sure you do number 2 on your pink study guide, and that you show your work and then put all of them into the correct bins.